something just happened behind the sun, where we couldn't see. October the 29th, 2025, 7:47. Eastern Time. The interstellar comet 3A Atlas reached perihelion, its closest approach to our star, 203 million count from the sun's surface. For the first time in 10 billion years, this object felt the warmth of another star system's furnace, and then it went silent. For 8 days, 3 Atlas was hidden from Earth's view, positioned directly behind the sun, our most powerful telescopes, blind, ground-based observatories, useless. The Manhattan-sized visitor from beyond our solar system performed its maneuver in complete privacy. But here's what makes your spine tingle. During those final hours before disappearing behind the sun, something changed. The comet began brightening rapidly, its glow intensifying at a rate that far exceeds any natural comet we've ever observed. And its colour, it turned bluer than the sun itself. Let that detail sink in for a moment. This object's surface should be freezing, hundreds of degrees colder than our star, yet somehow, impossibly, it's emitting light with a colour temperature hotter than the photosphere of the sun. Today, on October 30th, the Punch satellite constellation captured the first images of 3 Atlas emerging from behind the solar glare, and, according to NASA's automatic tracking systems, the comet maintained its expected trajectory. No deviation, no sudden course correction, no O-berth maneuver using the sun's gravity to redirect toward Earth. At least that's what the public data shows. But there are gaps, significant gaps. NASA allegedly has high-resolution images from the Mars Reconnaissance Orbiter taken when 3 Atlas passed within 30 million km of the red planet on October 10. So second, Harvard astrophysicist Avi Loeb requested those images. The response: silence. China's Purple Mountain Observatory, which tracked the object intensively through August and early September, stopped publishing data immediately after the Mars flyby. Their official reason: scheduling conflicts with lunar missions. The timing is curious, isn't it? This isn't speculation designed to fuel paranoia. This is about missing pieces in a puzzle that already doesn't fit, because even without those hidden images, what we can see defies comfortable explanation. Let me walk you through what happened during perihelion. What changed? What didn't change? And what still makes absolutely no sense? But first, we need to understand where this thing came from. And I'm not talking about another star system. I'm talking about something much stranger. The data suggests 3I Atlas is 10 billion years old. Our entire solar system is only 4.5 billion years old. This object existed before our sun ignited, before Earth formed, before anything you see in our cosmic neighborhood came into being. It's not just visiting from another star. It's visiting from another era of the universe. Think about that timeline. When 3 Atlas formed, the universe was less than half its current age. The first generation of massive stars had lived and died. The galaxy was still being shaped by violent mergers and collisions. And somewhere in that ancient cosmos, this object took shape. What kind of conditions create a comet that survives for 10 billion years? How does something remain intact through that much time? Through gravitational encounters with countless stars, through the radiation of multiple stellar environments, through the vast emptiness of interstellar space. The answer should be it doesn't. Natural. Comets are fragile. They're dirty. Snowballs held together by weak forces. Time destroys them. Radiation erodes them. Gravitational perturbations tear them apart. Yet here is 3 Atlas, ancient beyond measure, intact, functional, and actively venting gas as if it were freshly formed. Now, let's talk about what makes this object truly bizarre. Not the speculation, not the theories, just the raw, peer-reviewed, published scientific data. The facts that professional astronomers can't explain away with comfortable answers. Anomaly 1. Its trajectory. 3. Atlas isn't just passing through our solar system at a random angle. Its path aligns with the ecliptic plane, the flat disk where all our planets orbit to within 5 degrees. The statistical probability of this happening by chance. 0.2%, 1 in 500. But it gets weirder. Its arrival time was perfectly calibrated to bring it within tens of millions of kilometers of Mars, Venus, and Jupiter, and to position it directly behind the Sun, invisible from Earth during perihelion. The probability of all those alignments occurring naturally, 5 in 100. Serials, and you could argue coincidence. The universe is vast. Strange things happen. Fair enough. Let's keep going. Anomaly 2. The sun would jet. Between July and 1st August, multiple observatories, including the Hubble Space Telescope, documented something unprecedented. 3 Atlas was venting material directly toward the sun, not away from it like every normal comet. Toward it. Comets develop tails because solar radiation pressure pushes gas and dust away from the sun. It's fundamental physics. The tail always points away from the heat source, except when it doesn't. This wasn't an optical illusion caused by viewing angle. Multiple telescopes from different positions confirmed it. The sun would jet. What astronomers call an anti-tail persisted for weeks. Then, sometime in October, it disappeared. The comet's plume shifted direction. Now it behaves normally, venting away from the sun like it's supposed to. What kind of mechanism allows a comet to reverse the fundamental direction of its gas emission? What changed? Anomaly 3. The composition. When astronomers analysed the spectral signature of 3 Atlas's gas cloud, they found nickel. Lots of nickel. 4Gs. Continuously venting into space. That's not unusual by itself. Some comets contain metal compounds, but here's the problem. There's almost no iron. The nickel to iron ratio is completely wrong. In natural cosmic objects, iron dominates. Nickel appears as a trace element. The ratio found in 3 Atlas's plume matches industrial nickel alloys, human-made materials, not natural stellar chemistry. The probability of this ratio occurring naturally less than 1%, and the nickel to cyanide ratio orders of magnitude higher than any known comet, including Borisov, the other confirmed interstellar comet. The likelihood of the also less than 1%. Anomaly 4. Water content. Normal. Comets are ice balls. Water dominates their composition, typically 70 to 80%. By mass, 3I Atlas, 4% water, 4%. It's venting water vapor. Yes, that's how we detected its activity. But the actual water content is absurdly low compared to every comet we've studied. What kind of comet barely contains water? Anomaly 5. Extreme negative polarization. When light bounces off 3 Atlas, it exhibits a polarization signature never seen before. In any comet, including Boros, the measurement is so far outside the normal range that the statistical likelihood is, once again, less than 1%. Anomaly 6. The WOW signal connection. In 1977, the Big Ear radio telescope detected a powerful narrowband radio signal from space. It lasted 72 seconds. The signal was so strong, so clearly artificial looking that astronomer Jerry Ian wrote "wow" in the margins of the data printout. No one ever found the source. But here's the thing. 3 Atlas arrived from a direction in the sky that aligns with the WOW signal's origin point to within 9 degrees. The probability of that 0.6%. Could be coincidence, another dice roll. In an infinite universe, or maybe not, when you multiply all these individual probabilities together. The trajectory, alignment, the arrival timing, the sunward jet, the nickel ratio, the water, content, the polarization, the wow signal direction. You get a cumulative likelihood of less than 1 part in 10 quadrillion. 1 in 10 quadrillion. For context, the odds of winning the Powerball lottery are 1 in 292 million. You'd have to win the Powerball jackpot 34 million times in a row to match these odds. So, either 3. Atlas is the luckiest coincidence in astronomical history, or something else is happening. Now, let's be clear. Extraordinary claims require extraordinary evidence. The scientific method demands skepticism, and the vast majority of astronomers believe 3A. Atlas is a natural object, a comet, formed in another star system, ejected into interstellar space, now passing through our cosmic neighborhood by chance. That's probably correct. Nature is creative. The universe contains phenomena we haven't imagined. Absence of precedent doesn't equal impossibility, but ignoring anomalies doesn't make them disappear. And what happened during perihelion made those anomalies more pronounced, not less. Let me show you what I mean. Space-based solar observatories captured something extraordinary during 3 Atlas's final approach to the Sun. Multiple instruments operating independently recorded the same phenomenon. The comet brightened at an exponential rate, not the gradual brightening you'd expect from increased solar heating, not the steady ramp-up of sublimation as volatile ices warm and vaporize. This was different, aggressive, unprecedented. The brightness increased inversely with distance to the power of 7. 5. Let me translate that into plain language. As 3I Atlas got closer to the Sun, it didn't just get brighter linearly. The relationship was exponential, far steeper than any O'Rourke cloud comet at similar distances. And remember, O'Rourke cloud comets are fresh. They've spent billions of years in the deep freeze at the edge of our solar system. When they fall sunward for the first time, they contain pristine volatiles, maximum ice content. They should outgas dramatically. 3I Atlas has 4% water content. It's ancient, depleted. It shouldn't be capable of dramatic outbursting. Yet, there it was, blazing brighter with each passing hour. Stereo A solar observation spacecraft captured images with 2 different instruments. The HI-1 heliospheric imager and the CO2 coronagraph both showed the comet developing an extended halo. The glow stretched 300,000 kilometers outward from the nucleus. 300,000 km. That's almost the distance from Earth to the Moon. That's not a typical cometary coma. That's something else entirely. The SOHO spacecraft orbiting the Sun-Earth L1 range point confirmed the observation with its LASCO coronagraph, independent verification, multiple instruments, same result. And then there was GEO-19, the newest weather satellite equipped with the CCR1 compact coronagraph. It resolved details the others missed. The structure of that 300,000 kilometer halo wasn't uniform. It showed layering, complexity, organization. But here's where things get truly strange. The color. When astronomers analyzed the spectral data from LASCO and CCR1, they found something that shouldn't be possible. The light coming from 3E Atlas was bluer than the Sun. Pause on that. Think about what it means. When sunlight reflects off a comet, it should be the same color as the Sun, maybe slightly reined by dust. When a comet heats up and glows from thermal emission, it should be red or infrared. Cooler than the Sun, not hotter. The surface temperature of 3 Atlas even at perihelion, should be hundreds of degrees Kelvin colder than the Sun's photosphere. The Sun's surface temperature is 5800 Kelvin. That's what produces its yellowish-white color. 4. 3. Atlas to appear bluer than the Sun. Its emission source would need to be hotter, significantly hotter. We're talking about temperatures that don't occur on natural comet surfaces. So where's the blue light coming from? The research paper published on October 28th by Jiang and Datem states, quote, "The reason for 3 Atlas's rapid brightening, which far exceeds the brightening rate of most O'Rourke cloud comets at similar distances from the Sun, remains unclear. And regarding the blue color, they note it suggests emission contributes a substantial fraction of the overall visible brightness. Emission, not reflection. Something on or inside 3 Atlas is generating light at high temperatures. What kind of natural process does that? What kind of comet contains an internal heat source hot enough to emit blue light? The authors don't offer an explanation because there isn't a comfortable one. Now you might be thinking, couldn't this be fluorescent? Gas molecules excited by solar ultraviolet radiation then remitting light at shorter wavelengths. Possible. Some cometary gases do. Flues. Cyanide compounds, for example, can produce blue-green emission, but the scale is wrong. Fluorescence produces faint glows, not brightness that dominates the overall spectrum, and the observed blue shift was too pronounced for fluorescence alone to explain. You could argue for reflected light from an unusually bright, pristine, icy surface. But again, the scale doesn't work, and 3 Atlas is ancient. Its surface should be weathered, darkened by cosmic ray exposure over billions of years, not mirror bright. The data doesn't fit the models, and when data doesn't fit models, you have 3 options. 1. The data is wrong. 2. The model is wrong. 3. Something genuinely unexpected is happening. Let's assume the data is correct. Multiple independent instruments, different teams, same results. Hard to dismiss as measurement error. So either our understanding of cometary physics is fundamentally incomplete, or 3 Atlas is doing something comets aren't supposed to do, like operating an internal power source. I'm not saying it is. I'm saying the observations would be consistent with that hypothesis. An engine generating heat technology, maintaining functionality over 10 billion years of operation. A craft designed to use solar flybys for energy replenishment. Pure speculation, absolutely, but let's follow the thought experiment. If you were sending a probe on an interstellar journey lasting billions of years, how would you design it? You'd need extreme durability, redundant systems, and periodic energy replenishment, because even the most efficient power source degrades over geological timescales. Stars are convenient refueling stations, predictable, powerful. A close approach to a stellar photosphere dumps massive amounts of energy into any absorbing surface. If 3I Atlas were technological, a perihelion pass would be the perfect opportunity to recharge, absorb solar radiation, convert it to usable power, maybe even use the gravitational well for a trajectory adjustment if needed. But that's not what happened. According to NASA's automatic tracking data, 3 Atlas maintained its expected trajectory. No maneuver, no course correction. It came in, looped around, and continued outbound exactly where gravity predicted. So, if it is a probe, it's not interested in Earth. It's not altering course to investigate our planet. It's following its programmed route, passing through the solar system, gathering data perhaps, then continuing its eternal voyage through the galaxy. Or much more likely, it's just a really weird comet. But that blue light though, that keeps nagging at me. And there's another detail that doesn't fit. comfortably into the natural comet narrative. The timing of when things changed. Remember, the sun would jet. The anti-tail that persisted for weeks during July and August, violating basic cometary physics. That jet disappeared sometime in October, right around the time 3 Atlas passed Mars, right before it went behind the sun. When it re-emerged on October 30th, the plume had normalized. Now it behaves like a standard comet, tail pointing away from the sun. The anomaly corrected itself, or was corrected. Here's where we run into the information blackout. China's tracking data stopped after the Mars flyby. NASA hasn't released the high-rise images from Mars Reconnaissance Orbiter. The object was hidden behind the sun during its most critical phase. What we have is before and after. Before perihelion, anomalous behavior, sunward jet, strange composition. After perihelion, normalized tail, continued outgassing, maintained trajectory. What happened in between? According to Congresswoman Anna Paulina Luna, she's working to get those high-rise images released. Avi Lowe has been vocal about the need for transparency. Radio observatories are now monitoring 3 Atlas for any electromagnetic emissions, following Lowe's request to search for artificial signals. So far, nothing. No radio transmissions. No obvious signs of technology. Just a comet doing comet things, albeit in ways we've never quite seen before. The JWST spacecraft, currently en route to Jupiter, will observe 3 Atlas on November 2nd and again on November 25th. It's equipped with 5 instruments, a camera, a near-infrared imager, a UV spectrometer, a sub-millimeter instrument, and a sensor for detecting neutral atoms. JWST is half an astronomical unit away from the comet. That's 75 million kilometers. Too far for close-up imaging, but close enough for spectroscopy and compositional analysis. The data won't be downloaded until February 2026 because JWST's position relative to Earth results in extremely slow data transmission rates. So, we wait again. More gaps in the story. What we do know is that 3 Atlas survived perihelion intact. Some astronomers predicted it might fragment. Comets are fragile. The thermal stress of a close solar pass can tear them apart, especially if they're loosely bound rubble piles. 3 Atlas didn't break, despite being heated to 770 watts per square meter at perihelion, despite the enormous gravitational forces near the sun, despite being 10 billion years old and presumably weakened by eons of cosmic weathering. It held together. That tells us something about its internal structure. It's not a loosely bound rubble pile. It has structural integrity, strength, cohesion. You could argue this is evidence of natural formation processes. Some comets are indeed monolithic, formed as single, frozen bodies rather than accreted from smaller pieces. Perfectly normal. Or you could note that 10 billion years is a hell of a long time for any natural structure to remain coherent. Micrometeorite bombardment alone should have eroded and fractured the surface. Over that timescale, cosmic ray damage should have weakened the internal structure. Yet here it is, intact, functional, venting gas like a fresh comet despite having found water content. Let me give you another piece of the puzzle, one that Avi Lowe discussed on the Joe Rogan podcast. The nickel emission, 4 grams per second, continuously, for months. Do the math. From discovery in July to perihelion in late October, that's roughly 4 months, 120 days, 10 million seconds. 4 years, 10 million seconds equals 40 million years. 40 kill, 40 metric tons of nickel, vented into space from an object that's, 5 kilometers in diameter with a total mass of 30 billion kg. 40 tons of nickel is roughly 1 millionth of its total mass doesn't sound like much. But remember, this is pure nickel, not nickel-bearing minerals, not trace amounts embedded in rock. This is gaseous nickel ionized free in the material plume. Where is it coming from? How is it being liberated from the surface or interior? Normal sublimation doesn't work. Nickel has a boiling point of almost 3,000 degc, the surface of 3I Atlas. Even at perihelion doesn't reach temperatures high enough to vaporize metallic nickel. You need energy input, lots of it, either from an internal source or from some exotic surface chemistry we don't understand. And again, that nickel to iron ratio, it's cosmically wrong. The universe makes iron and nickel together in specific proportions through stellar nucleosynthesis. Finding nickel without corresponding iron is like finding smoke without fire, unless the nickel isn't coming from natural ore, unless it's coming from manufactured components, alloys, structural materials designed for specific properties. I know how this sounds. I do. We're pattern matching, seeing design where randomness might exist. It's a cognitive bias humans can't escape. We're wired to see intention behind unusual events, but sometimes unusual events do have intention behind them. The challenge is distinguishing between the two, and right now with missing data, hidden observations, and gaps in the timeline, we're operating with incomplete information, which brings me to the elephant in the room that I've been dancing around. What if it is artificial? What would that mean? Let's think about scale for a moment. Our most ambitious spacecraft, SpaceX's Starship, stands 120 meters tall. It can carry 100 tons to low Earth orbit. It's the pinnacle of human rocket engineering. 3E Atlas is 5,000 miles across, maybe larger. Its mass is 30 billion kilo. That's 300 million Sol times heavier than Starship's payload capacity. If 3T Atlas were technological, its builders would have mastered capabilities so far beyond our current level that comparison becomes meaningless. We're talking about a civilization that can construct objects the size of mountains, accelerate them to interstellar velocities, and keep them operational for 10 billion years. 10 billion years. Human civilization is roughly 10,000 years old, recorded. History spans maybe 5,000 years. Our entire species, Homo sapiens, has existed for only 300,000 years. 10 billion years ago, Earth didn't exist. The Sun didn't exist. The molecular cloud that would eventually collapse to form our solar system hadn't even begun to condense. Any civilization capable of building 3 Atlas would have emerged in a younger, stranger universe. They would have witnessed cosmic evolution on scales we can barely imagine. They would have solved problems we haven't conceived of yet. And if they sent probes, why wouldn't those probes be designed to last, to observe, to gather data across geological time scales? A vibe makes a compelling point. The discovery of technological artifacts from other civilizations would be the most profound revelation in human history. It would answer the fundamentals question, are we alone? The implications extend beyond philosophy. If interstellar probes exist, if they're common enough that one passes through our solar system every few decades, then the galaxy might be filled with them. Ancient observers, quietly mapping the cosmos, reporting back to civilizations that may no longer exist or still do. Think about that possibility. Right now, as you process these words, there might be billions of probes scattered throughout the Milky Way, silent witnesses to stellar birth and death, to planet formation, to the emergence of life. Some of them might be watching us, but let's pull back from speculation and return to what we know, what we can measure, what we can test. The International Asteroid Warning network has initiated a formal campaign to monitor 3 Atlas, starting November the 27th and continuing through January 27th, 2026. Multiple observatories will coordinate observations. The campaign will include workshops on astrometry, the precise measurement of celestial positions and motions. Why? Because tracking potentially hazardous objects requires accuracy, and 3 Atlas, while not hazardous to Earth, serves as a perfect test case. It's large, it's bright enough to observe, and it's interstellar. Trajectory provides unique challenges for tracking algorithms. But there's another reason, an unstated one. If 3I Atlas were to maneuver, even slightly, we'd detect it. Any deviation from its gravitational trajectory would be immediately obvious to the coordinated network of observatories. So far, nothing. The object continues on its predicted path. Pure ballistic. Motion. No thrust. No course corrections. Just gravity doing its thing. That's evidence against the artificial hypothesis. A strong data point. Probes maneuver. They adjust. They react to their environment. 3. Atlas isn't doing any of that. Or perhaps it already did. Perhaps the trajectory we're observing is the result of a maneuver performed centuries or millennia ago. Once you're on the right path through interstellar space, why waste energy on further corrections? Coast. Observe, record. The upcoming observations in December will be critical. On December the 19th, 3I Atlas reaches its closest approach to Earth, 269 million km. That's almost twice the distance from Earth to the Sun. But it's the closest we'll get. Ground-based telescopes will have optimal viewing conditions. The Hubble Space Telescope will observe it. The James Webb Space Telescope will observe it. Every major observatory on the planet will point their instruments at this object. They'll analyze its spectrum in unprecedented detail, map its surface features, measure its rotation, look for any signs of internal structure, search for heat signatures that don't match solar heating patterns. And they'll listen. Radio telescopes around the world will monitor 3A Atlas for electromagnetic emissions, any signal, any pattern, any deviation from random noise. If it's a probe, December might reveal it. If it's transmitting data back to its origin point, we might intercept that transmission. If it's using active sensors to scan Earth, we might detect the radar or LR pulses. But here's the uncomfortable possibility. What if it's designed not to be detected? What if it's been engineered to masquerade as a natural object? Passive observation, minimal emissions, camouflage indistinguishable from a real comet. How would you even test for that? How do you prove that the absence of artificiality when the word artificial could be designed to mimic the natural perfectly? You can't. Not definitively. You can only accumulate evidence, look for inconsistencies, find the places where the disguise fails, and 3 Atlas has inconsistencies, 9 of them. Now, if we add the blue light emission to the list, 9 anomalies that don't fit comfortable explanations. But 9 anomalies don't equal proof. They equal mystery. And mysteries can have mundane solutions. Let me offer a natural explanation that accommodates most of the observations. Suppose 3 Atlas isn't a typical comet. Suppose it's something rarer. A fragment of a disrupted planet. A shard of a world torn apart by tidal forces during a close stellar encounter. Billions of years ago, planetary fragments would have different compositions than comets. They'd contain metals, core material, nickel iron, alloys from the planet's interior. If 3 Atlas were such a fragment, the nickel emission makes sense. It's venting material from deep inside, exposed when the parent body shattered. The low water content explained. Planetary interiors are dry compared to comets. The structural integrity Explained, solid rock and metal, not fluffy ice. The age explained, planets form early. Fragments could be 10 billion years old. What about the blue light? If the fragment contains radioactive isotopes, internal heat from radioactive decay could drive chemical reactions on the surface. Exotic chemistry producing emission lines we don't typically see in comets. The sunward jet may be related to localized venting from specific surface features, geysers triggered by internal pressure, aimed in directions determined by the fragment's rotation and structural processum weaknesses. See, you can construct a natural narrative. It requires a specific set of circumstances, sure, but those circumstances aren't impossible, unlikely, perhaps, but not impossible. The question becomes which is more likely, a rare natural object with multiple unusual properties or artificial technology from an extinct civilization. Most scientists would say the natural explanation, however unlikely, is still more probable than the artificial one because we have zero confirmed examples of alien technology, but we have billions of examples of natural objects doing strange things. The prior probability matters. Extraordinary claims require extraordinary evidence, and right now, the evidence is circumstantial, suggestive, intriguing, but not definitive. So where does that leave us? We watch, we wait, we gather more data, and we prepare for both possibilities. If 3E Atlas is natural, understanding it will revolutionize our knowledge of planetary formation, stellar system dynamics, and interstellar object composition. It's a messenger from the ancient universe, carrying information about conditions and processes that no longer exist in our modern cosmos. If 3 Atlas is artificial, well, everything changes. The Fermi paradox shifts from philosophical puzzle to solved mystery. We're not alone. We never were. The galaxy is populated or was populated by civilizations capable of reaching across the stars. And if they could do it, eventually, so can we. But here's what troubles me most about the artificial hypothesis. If 3 Atlas is a probe, it's not interested in us. It passed Mars within 30 million kilometers. That's close. Close enough to image the surface at high resolution. Close enough to detect our rovers, our satellites, our infrastructure. If it wanted to investigate Earth, it could have a small trajectory adjustment during the Mars flyby would have brought it much closer to our planet. Instead, it maintained course. It prioritized perihelion over Earth examination. What kind of probe does that? What would be more interesting to an alien intelligence than a planet with technological civilization? Unless it already knew we were here, unless it had scanned us from a distance and determined we weren't worth a closer look, or perhaps we weren't its mission priority. Perhaps it was surveying the sun, not the planets, gathering stellar data, not biological data. Or maybe, just maybe, it did investigate us. Maybe it deployed smaller probes during the Mars flyby, subcraft too small to detect. Miniature observers now in orbit, around Earth, watching, recording, waiting. Pure speculation, science, fiction territory. But the universe has proven itself stranger than fiction. Repeatedly, black holes exist, neutron stars exist, galaxies collide and merge. Reality keeps surprising us with phenomena we couldn't have predicted. So, why not this? Why not ancient probes traversing the galaxy? The answer might be coming. December will tell us more. February 2026, when JWST's data downloads will tell us even more. And the observations between now and then might reveal something unexpected, or confirm that 3I Atlas is exactly what it appears to be, a very old, very strange comet with properties we don't fully understand yet. But either way, we've learned something profound. The universe delivers mysteries to our doorstep. objects from beyond our solar system, carrying signatures of alien environments, reminding us that the cosmos is vast and our understanding incomplete, whether 3i Atlas is natural or artificial. It's teaching us, forcing us to question assumptions, pushing the boundaries of what we think is possible. And maybe that's the real value, not the answer, but the question, not the certainty, but the wonder, because that's what drives science forward. That's what propels humanity to explore the possibility that something extraordinary might be real, that the universe might be stranger, more populated, more alive than we dared imagine. So, we point our telescopes, we collect photons from objects 10 billion years old, we analyze spectra, we measure velocities, we build models and test hypotheses, and sometimes, just sometimes, the data refuses to fit our comfortable boxes. That's when things get interesting. Right now, as of October 31st, 2025, 3i Atlas is moving away from the Sun at 210,000 km every hour. It travels farther from the warmth that briefly illuminated it every day. It gets colder, darker, more distant. It's currently within the orbit of Mars, but that won't last long. By mid-November, it will cross Mars' orbital path and continue outward. By December, it will be approaching the asteroid belt's outer edge. By the end of 2026, it will pass Jupiter's orbit and begin the long journey back to interstellar space, and will be watching every moment of that departure. The viewing conditions are improving for Earth-based observers. During perihelion, 3e Atlas was lost in the Sun's glare, observable only by specialized space-based coronagraphs. Now, as the angular separation between the comet and the Sun increases, conventional telescopes can see it starting this weekend. Amateur astronomers with decent equipment will be able to spot 3e Atlas in the pre-dawn sky. It will appear near Venus, rising before the Sun, not bright enough to see with naked eyes, but visible through telescopes, a fuzzy patch of light, a visitor from another star system close enough to photograph from your backyard. That's remarkable when you think about it. How many people throughout human history have looked at the stars and wondered what lies beyond? How many civilizations dreamed of touching something from another world? And now you can point a telescope at 3 Atlas and observe directly an object that formed in another stellar system. You're collecting photons that bounced off material created under alien conditions. You're witnessing in real time a fragment of a different cosmic environment. Professional observatories are coordinating their efforts. The European Southern Observatory, with its array of telescopes in Chile, will track 3 Atlas throughout November and December. The KEK Observatory in Hawaii will observe it. The Very Large Telescope will observe it. Subaru, Gemini, Mellin, every major facility will contribute data. They're looking for specific signatures, changes in brightness that might indicate outgassing events, variations in the spectrum that could reveal compositional differences across the surface, polarization patterns that might tell us about particle sizes in the coma, and they're looking for anything unusual, any deviation from expected behavior, any sign that 3 Atlas is more than it appears. The Hubble Space Telescope has already observed 3 Atlas multiple times. Back in July, Hubble captured the famous image showing the sunward jet. That single photograph revealed the anti-tail that sparked so much scientific debate. In December, Hubble will observe again, multiple sessions, multiple filters, maximum resolution. The images will show surface features if any exist. They'll map the dust distribution. They'll measure the rotation period with precision. And, crucially, they'll look for changes. Compare the December images to the July Images. Has the surface altered? Have new vents opened? Has the activity patterns shifted? The James Webb Space Telescope will join the observation campaign. Webb operates in infrared, detecting heat rather than visible light. That's perfect for studying comets. Infrared reveals temperatures, compositional details, subsurface, structure. Webb will map the temperature distribution across 3 eye atlases. Surface. It will identify hot spots, cold spots, regions that are emitting more heat than solar radiation alone. Explain. If there's an internal heat source, Webb will find it. The SpaceX Space Observatory already detected the carbon dioxide plume back in August. That observation showed the gas clouds extending outward, measuring its composition and velocity. In December, SpaceX will observe again, looking for changes in the plume's characteristics. Has the CO2 production increased or decreased? Has the nickel emission continued? What about water vapor? Is it still present at 4% or has the concentration changed? These aren't trivial questions. They tell us about the object's interior. How deep do the volatiles extend? What's driving the outgassing? Is it purely solar heating or is something else contributing? Radio observatories are listening. The Very Large Array in New Mexico. The Aribo Replacement Facilities. The Square Kilometre Array. Even SETI Institute instruments are pointing at 3 Atlas. They're scanning across the electromagnetic spectrum looking for narrow band signals, broadband, transmissions, repetitive patterns, anything that doesn't match natural emission. Avi Loeb specifically requested this after noting the WOW signal connection. He argued that ruling out artificial signals is essential. If 3 Atlas is transmitting even weakly, we should be able to detect it at its current distance. So far, silence, just the natural radio emission you'd expect from a comet's interaction with the solar wind. No coherent signals, no patterns, no obvious technology. But absence of detection doesn't equal absence of signal. Maybe it's transmitting on frequencies we're not monitoring. Maybe it's using directional beams aimed away from Earth. Maybe it's not transmitting at all, operating in receive-only mode, passively collecting data. Or maybe it's just a comet and there's nothing to detect. The Chinese space program, despite going silent after the Mars flyby, has resources in position. The Chang'e 7 lunar mission is preparing for launch. But China's deep space network remains active. Their radio dishes can observe 3 Atlas if they choose to. Whether they're sharing that data is another question. This brings up an uncomfortable truth about modern astronomy. It's increasingly politicized. Nations compete for discovery priority. Data becomes strategic. Transparency suffers when national interests are at stake. If China did detect something unusual during their September observations, would they release it publicly, or would they classify it, analyze it internally, and only release information after securing whatever advantage it provides? Same question applies to the United States. Those Mars reconnaissance orbiter images, why haven't they been released? Is it really just bureaucratic delay? Or is there a reason NASA wants to review them privately first? Congresswoman Luna's involvement suggests political pressure is mounting. Scientists want the data, the public wants the data, but institutions move slowly, especially when the implications might be significant. And make no mistake, the implications are significant. If those high-rise images show anything anomalous, surface, features that look artificial, geometric, patterns, structures inconsistent with natural formation, the revelation would be historic, but it would also be destabilizing. How do you tell the world that an alien probe passed through the solar system? How do you manage the reaction, the questions, the fear and excitement and confusion. Maybe you don't release it all at once. Maybe you prepare the narrative. Maybe you wait until you have enough data to provide context, explanation, reassurance. Or maybe the images show nothing unusual, and the delay is exactly what NASA said: scheduling conflicts, data processing, backlogs, normal bureaucratic friction. We'll find out eventually. Data has a way of leaking. Someone on one of those teams will talk. An astronomer will share images at a conference. A researcher will post preliminary findings online. The truth, whatever it is, will emerge. But while we wait for that truth, the observations continue. Every telescope, every instrument, every wavelength, building the most comprehensive dataset ever collected for an interstellar object. By the time 3 Atlas leaves the inner solar system, we'll know more about it than we know about most comets that formed in our own neighborhood. We'll have spectroscopy, photometry, polarimetry, radio data, thermal imaging, optical imaging, and compositional analysis. And from all that data, patterns will emerge, answers will crystallize. The anomalies will either resolve into natural explanations or persist as genuine mysteries. December the 19th is the keystone date. Closest approach to Earth. Optimal viewing geometry. Maximum instrument. Time allocated. If something's going to be revealed, that's when it happens. Imagine the scenario. December 20th. News breaks. Webb telescope detected anomalous heat. Signatures or Hubble imaged geometric. Surface features or radio telescopes picked up a signal. The headlines write themselves. The world stops. Confirmation that we're not alone. That intelligence exists beyond Earth. That the universe is populated. Or imagine the alternative. December 20th. News breaks. All observations consistent with natural. Comet anomalies explained by unusual but non-artificial processes. 3 Atlas is interesting, ancient, valuable for science but not technological. The world shrugs, moves on, forgets about the interstellar visitor that almost was. Which outcome would you prefer? Which outcome do you expect? I'll be honest, I don't know what I hope for. The romantic part of me wants 3I Atlas to be artificial. Wants confirmation that we're part of a cosmic community. Wants to know that intelligence is common, that the universe is alive with civilizations, building and exploring and reaching across the stars. But the rational part of me recognizes the complications. Contact, even passive contact through discovering an artifact changes everything. Our place in the universe shifts. Our priorities reorganize. Questions about meaning and purpose and future acquire new dimensions. And there's fear, too. If they're out there, why haven't they made contact? Where is everyone? If probes are common. If 3E Atlas is just one of many. Why? The silence. Maybe we're being observed, studied, catalogued, filed away in some vast database of emerging civilizations, waiting to see if we survive long enough to matter. Or maybe 3 Atlas is a who? Relic. A ghost ship from a civilization that died billions of years ago. Alone. Now. Eternal. Witnessing the universe on autopilot. Reporting to masters that no longer exist. That's almost sadder than being alone. Knowing they existed. Knowing they built wonders. Knowing they're gone now. And all that remains are their probes wandering the galaxy forever. But these are emotional reactions, not scientific analysis. What matters is the data, the observations, the measurements, and those are coming. Week by week, instrument by instrument, we're collecting the evidence that will answer the question. So, I'll make a prediction. By February 2026, when JWST's data downloads complete, when the December observations are fully analysed, when all the instruments have reported their findings, We'll have a consensus, not proof, not certainty, but a scientific consensus about what 3E most likely is. My guess, it's natural, a weird, ancient, compositionally unusual fragment of a disrupted planetary system ejected into interstellar space billions of years ago, now passing through our solar system by chance. But I could be wrong. The universe has surprised us before, and wouldn't it be something if this time the surprise was intelligence? Let's zoom out for a moment, away from 3 Atlas, away from the specific measurements and anomalies. Let's look at the bigger context. We've now detected 3 confirmed interstellar objects passing through our solar system. Oumuamua in 2017, Borisov in 2019, Atlas in 2025. 3 objects in 8 years. Statistical models suggest these detections represent a tiny fraction of the actual population for every interstellar object we spot. Hundreds or thousands pass through unnoticed. Too small, too dark, wrong trajectory, bad timing. The galaxy might be thick with interstellar debris, fragments of disrupted planetary systems, ejected comets, wandering asteroids, material scattered across the spiral arms, drifting between stars, occasionally falling into a solar system's gravity. Well, we're only now developing the technology to see them better. Telescopes, automated survey systems, sophisticated tracking algorithms. As our detection capabilities improve, we'll find more, and every one of them will be a time capsule, a sample of another star's environment, a piece of stellar history delivered to our doorstep. But here's the interesting thing. Oumuamua was strange, anomalous acceleration, cigar-shaped or pancake-shaped, depending on interpretation. Bright surface inconsistent with typical asteroidal composition. Borisov was normal, a textbook comet, water ice, carbon compounds, typical outgassing, predictable behavior, exactly what we expected an interstellar comet to look like. And now, Atlas, strange again, multiple anomalies, behaviors that don't fit comfortable models. 2 out of 3 interstellar visitors have been weird. That's either bad luck in our sampling, or weirdness is more common than we assumed. If weirdness is common, why? What makes interstellar objects different from solar system objects is the environments they formed in, the processes that ejected them, the effects of travelling through interstellar space for billions of years. Or is it something else? Could some fraction of interstellar objects be artificial? Not all of them, not even most of them, but some. If civilizations arise commonly throughout the galaxy, and if those civilizations build probes to explore their stellar neighborhood, then over billions of years, the cumulative number of probes would be enormous. Think about it. One civilization sends out 10,000 probes. Those probes travel for millions of years, mapping nearby stars. That civilization dies out, but the probes continue. Another civilization arises, sends out their probes. They die out. 2 probes keep going. Over galactic history, millions of civilizations could have existed and vanished, each one potentially contributing probes to the interstellar environment. By now, ancient probes might outnumber natural interstellar objects in some regions. This is the hypothesis Avi Low keeps returning to, not because he's committed to it being true, but because it's testable. You can look for signatures. You can analyze anomalies. You can accumulate evidence that either supports or contradicts the possibility. And if even one interstellar object turns out to be artificial, everything changes. The Fermi paradox collapses. The great filter becomes less terrifying because at least one civilization survived long enough to build interstellar probes. We're not necessarily alone. We're not necessarily doomed. The universe has proven that intelligence can emerge, develop technology, and reach for the stars. That's worth investigating. That's worth the telescope time, the analysis effort, the scientific scrutiny, because the payoff, if positive, is incalculable. But even if 3 Atlas is natural, its value is immense. We're learning about planetary formation in other stellar systems. We're studying material that experienced different chemical processes, different thermal histories, different evolutionary pathways. Every measurement refines our models. Every spectrum adds data, points. Every observation teaches us something about the diversity of cosmic environments. And that knowledge is practical. Understanding how planetary systems form and evolve helps us predict which exoplanets might harbour life. Understanding cometary compositions helps us trace the origin of Earth's water and organic compounds. Understanding interstellar dynamics helps us map the galaxy's structure and history. Science builds incrementally, brick by brick, observation by observation. 3 Atlas is one more brick in that edifice. Unusual, yes. Anomalous, certainly, but still part of the larger construction of human knowledge. So what should you take away from this story? What's the message? First, pay attention to the anomalies. When data doesn't fit expectations, that's where discovery happens. That's where our models get refined or replaced. Easy answers are satisfying, but nature doesn't care about our comfort. Second, remain skeptical but open. Extraordinary claims require extraordinary evidence, but evidence can be extraordinary if you collect enough of it. Don't dismiss possibilities just because they seem unlikely. Calculate probabilities. Test hypothesis. Follow where the data leads. Third, the universe is stranger than we imagine. Black holes sounded like science fiction until we detected them. Exoplanets were theoretical until we found them. Gravitational waves were mathematical. Predictions until LIGO heard them. Reality keeps surprising us. What sounds impossible today might be textbook material tomorrow. And fourth, we're living through a golden age of astronomy. More telescopes, better instruments, faster data processing, international collaboration. For the first time in history, we can study interstellar objects in real time. We can track asteroids from other stars systems. We can analyze their composition, measure their properties, test hypotheses about their origin. Our grandparents couldn't do this. Our ancestors couldn't even dream of this. But we can, right now, today. And 3 Atlas is just the beginning. More interstellar objects are coming. Better detection systems are coming online. Within a decade, we might be tracking dozens of visitors. Within a century, we might be sending our own probes to intercept and study them up close. The galaxy is opening to us slowly, gradually, but inexorably. Every year, we see farther, understand more, discover wonders we couldn't have anticipated. So when 3 Atlas fades from view, disappearing back into the darkness between stars, it won't be the end. It'll be a chapter. One story in an expanding library of cosmic encounters. And maybe, just maybe, one of those encounters will be the one that changes everything. The one that proves we're not alone. The one that answers the oldest question humanity has ever asked. Are we the only intelligence in the universe? The answer might be coming. Not today, not this year, but soon, within our lifetimes. Potentially, as we explore more, detect more, analyze more. The probability of discovering evidence of other civilizations increases, and when that discovery happens, if it happens, I hope we're ready. Ready for the implications, ready for the questions, ready for the transformation of perspective that comes with knowing, truly knowing that intelligence exists beyond Earth. But until then, we watch the skies, we point our telescopes, we collect data, we analyze, we debate, we wonder, because That's what humans do. We're curious, we're explorers, we're builders of instruments that extend our senses across the cosmos. We're creatures who look at points of light in the night sky and ask, what's out there? 3 Atlas gave us a glimpse, a tantalizing, confusing, anomalous glimpse. Not enough to answer definitively, but enough to keep asking. And sometimes the questions matter more than the answers. The questions drive us forward, push us to build better telescopes, develop smarter algorithms, collaborate across borders and disciplines. The questions remind us that we don't know everything, that the universe still holds secrets, that discovery is possible if we're willing to look. So look up this weekend. If you have access to a telescope, point it near Venus in the pre-dawn sky. Find that fuzzy patch of light, that visitor from another star, that 10 billion-year-old mystery. You'll be observing directly an object that formed before the sun existed. You'll be collecting photons that travelled across interstellar space. You'll be participating in a small way in one of the greatest scientific investigations of our time. And maybe as you watch that fuzzy patch drift across the field of view, you'll feel what I feel, a sense of connection to the cosmos, to the deep history of the universe, to the possibility that somewhere, sometime other minds have looked at the stars and wondered the same things we wonder. Are we alone? 3 Atlas doesn't answer that question. Not yet. Maybe not ever. But it reminds us to keep asking. And as long as we keep asking, keep observing, keep analysing, keep wondering, we're moving toward the answer. However long it takes, however many interstellar visitors we must study, however many anomalies we must investigate, the answer is out there somewhere, waiting to be discovered. And the next fuzzy patch of light we spot in our telescopes, the next interstellar wanderer that drifts through our solar system, that might be the one that finally tells us the truth. So stay curious, stay skeptical, stay open, and keep watching the skies, because you never know what might be coming next.